A laser rangefinder is locked on a comet approaching Earth. So the distance after x days is given by this function g of x. So we're supposed to sketch the graph of g of x. Before we do that, let's talk about why the graph of cosecant x is the way it is. That'll help us with this graph. Okay, like if you think about x equals pi, if you plug in pi into cosecant, remember cosecant is just 1 over sine, right? And sine of pi, we've learned, is 0. So this is 1 divided by 0, which can't compute, right? So x equals pi is actually going to be a vertical asymptote, because as you get closer and closer to it, you start going further off into infinity. And just a reminder, why is sine pi equal to 0? Because sine is the sine is the y coordinates on the unit circle. So if you draw the unit circle, and if you actually just draw just pi, half the unit circle, you're at -1, 0. Sine is 0 because sine is the y coordinate. And same thing for x equals 0. Cosecant of 0, that's 1 over sine of 0. And if you graph sine of 0, and if you're trying to figure out what this is, that means 0 degrees rotation. That's 1, 0 for a point. And so if you try to evaluate this trig function at 0 for an angle, the sine of the angle is going to be the y coordinate. It's also 0. So the long and short of it here is that cosecant x, it starts looking like this horseshoe shape. It reaches 1, but it never quite reaches at x equals pi. There's vertical asymptotes here. And then it keeps making those horseshoe shapes. It keeps inverting itself. And this way and this way. And you could evaluate that. Oops, and that's probably should go to -1. You can figure that out because if you try to plug in some values for x, you're going to see that they're negative, then positive, then negative. So the graph of cosecant x looks something like this. Okay, so that's important because with this crazy looking function, we want to look out for when the inside of the cosecant function is going to be pi or 0 or anything like that, right? If you were to plug in pi right now for x, pi times pi makes pi squared, doesn't come out to anything nice. But what if you plug in, I can just delete all this, what if you plug in x equals 24? Then if you try to simplify this, this is 200,000 cosecant. 24 times pi over 24 just makes pi of x, right? And so this is going to cause us to have, oh sorry, we already plugged in something for x, we plugged in 24. Cosecant of pi, we just saw, is undefined because it's making an asymptote. It's 1 divided by 0. So the graph is going to have some sort of asymptote at x equals pi. And same thing if you were to plug in x equals 0 in here. If you plug in 0 for x, then pi over 24 times 0 just makes 0, and we saw that that was also undefined. So we should be expecting to see some sort of shape like this. Okay, and to get a more accurate reading, maybe we want something in between. So let's see what happens when we plug in x equals 12, because that's halfway between those two, the first two vertical asymptotes that we talked about. So if we plug in 12 in here, that's not something that comes out nice and clean. Sorry, I had to stop the video because I plugged in 12 incorrectly. If you plug in 12 in for x, that'll be something sort of in between these two vertical asymptotes. So let's see what that is with our calculator. I'm going to do 12 times pi divided by 24, and I'm going to hit trig. I'm already in radians. Make sure you're in radians, okay? Because if we're using pi, probably safe to assume that we're talking about radians for x. So hit trigonometry, then go to cosecant. So that gives us 1. And then 1 times 200,000. That gives us 200,000 for the y variable. So g of 12 gave us 200,000. Because this is 1, and 1 times 200,000 is 200,000. So our graph, we should go with a graph that has a really high value on the y-axis. So at x equals 12, we reach the bottom. That's halfway in between. And x equals 24, and at x equals 0, we're hitting vertical asymptotes. And x equals 12, we've hit our limit. And x equals 24, we go off to positive infinity. Okay, so you could try to use Desmos for that, but it's going to be hard because Desmos can't fit all this on. You know, that graphing calculator mentioned in other videos. There we go. There's a rough sketch of the first, not even a full period yet. But. Evaluate g of 4. So that means we're just supposed to plug in, just like we evaluate g of 12. G of 4 means plug in 4 for x. And so if we simplify, you've got 200,000 cosecant, and then inside here we have pi over 24 times 4. The 4 and the 24 are going to reduce each other with cross simplification. 4, 8, 12, 16, 20. Makes pi over 6 when we reduce that. Pi over 24 times 4 gives us pi over 6. And then if you use a calculator, let's do pi, divide by 6, and then hit trigonometry, cosecant, and it gives us 2. Okay? If it didn't, let me see. That'd be a 30-degree. Yeah, so if it doesn't give you like 2 or something like that in your calculator, if you do pi, if it's like pi over 8 or something like that, you could use your right-angled trig and using one of those special triangles. Let's say it was pi over 4. Cosecant pi over 4. So if you do pi, divide by 4, and then hit cosecant, doesn't give us anything nice and clean, right? So instead what we can do is we can recognize pi over 4. That's, if we convert that to degrees, you know, multiply by 180 and then cut the pi out, that gives us a 45-degree angle. And so that means we're working with the second of those two special triangles where both the side lengths that aren't the hypotenuse are square root of 2 over 2. Okay, so you have to go back to what we do that past week. And so cosecant is the reciprocal of sine. It's the hypotenuse divided by the opposite. So the exact value we'd be working with here, if you got cosecant pi over 4, it would be like 2 over the square root of 2. Okay, so you're going to have to go back to what we did last week when it asked for exact values. Try it with the calculator. Maybe it'll come out to something like an integer, like I got an integer of 2. Cosecant pi over 6 is 2. But you're probably going to have to use right-angled trig. I'll try to go back and see if I can look at other students' variation of the question. So we got 200,000 times 2, which equals 400,000 for part B. 400,000 when I plugged in 4 in for T. Okay, I'm going to erase this so I have room for part C. This is a big question. C, what is the minimum distance between the comet and the Earth? We actually already found that in our investigation up above, right? Because of the way cosecant works, cosecant hits its minimum right in between those two vertical asymptotes that we graphed, right? There's a vertical asymptote at t equals 0, vertical asymptote at t equals 24. In between, exactly in between is t equals 12. So that is when it hits. It occurs at day 12. Okay? The minimum distance between the comet and the Earth, what's the value that we got when we plugged in g equals 12? We got 200,000. And they call this the stretching factor. I've already got it highlighted here. The 200,000, when you multiply it to the cosecant function, it just stretches it and makes it go up and down at a lot faster and faster rate. So the number multiplying to a is a stretching factor. Period, you choose that if the number you're talking about is the number that affects how often something repeats itself. Part D says, whoop, sorry, accidentally clicked my kid's video game there. We're supposed to find and discuss the meaning of any vertical asymptotes on the interval 0 to 28. We've been talking about the vertical asymptotes. We have 0 and then put a semicolon and 24 for my vertical asymptotes. Right? Because vertical asymptotes happen when cosecant equals 0 and when cosecant equals pi. So if you plug in 24 in here, 24 times something over 24 cross cancels, so you just get cosecant of pi. So that's what makes the vertical asymptotes happen. And what's the meaning of those vertical asymptotes? At the vertical asymptote comment is, oh, I got to check this list. The vertical asymptotes mean that it's just so far away. Eventually, it's beyond the capabilities of our instruments to measure, right? So as it gets closer and closer at a faster and faster rate. So at time t equals 0, can't even tell what the comet is, how far away it is. Time t equals 24, it's now gone past, and we don't even know how far away it is. In this drop-down list, I would choose it's out of range for the laser at the vertical asymptotes, because we said that's to a point where the laser can't even reach. It's so far away from us, we can't even tell where it is. It was a big one, and I actually just looked. It doesn't say 200,000. It says something like scientific notation. So just do the math to figure out what the value is over here. It might be 2 times 10 to the 1, 2, 3, 4, 5, 10 to the 5th power. It'll probably look like something like that, which is the same thing as 200,000. Okay, that's a big one, but I hope this video at least helps you with some of the parts, and you can always message me and tell me what you're trying on the part that you're working on, and I can help you through it.